Hello, welcome. In this short video, let us look at an example illustrating that the standard Neyman-Pearson theorem based likelihood ratio test may not result in a simple test statistic. From previous videos, we know that in the case of a linear model with noise following a simple white Gaussian structure or white Gaussian distribution, and if you are trying to find the DC level against the white Gaussian noise, that is, you want to detect a DC level, then the standard Neyman-Pearson theorem based likelihood ratio test basically results in a simple test statistic. That is, the statistic is a sample mean. However, when the noise is more complicated than a simple Gaussian distribution, say for example, it is a mixture of multiple Gaussian distributions, then the likelihood ratio test may not simplify to a well-defined test statistic. So, let us look at the example. Under the null hypothesis, we have the model x of n is equal to the noise w of n, where n is values from 0 to n minus 1. Under the alternate hypothesis, we have the model x of n is equal to a DC level plus the noise component w of n, where n again has values from 0 to n minus 1. Here, the general structure of the noise is a probability distribution p of w of n. So the likelihood ratio test L of x will have the probability distribution of the observation vector x under the alternate hypothesis h1 with the ratio is with probability distribution under h0, and it should be greater than a threshold gamma. So in order to find these distributions, we proceed as follows. Under the null hypothesis, the probability distribution is clearly equal to the product n equal to 0 to n minus 1, the distribution of each observation under the null hypothesis. And since under null hypothesis x of n is equal to w of n, so the distribution should be equal to distribution of w of n. So clearly this is equal to n equal to 0, n minus 1, probability distribution of w at x of n. So this is the probability distribution of the observations under h0. Under the alternate hypothesis, the distribution is the product n equal to 0 to n minus 1, probability distribution of x of n under h1. We can find the probability distribution of x of n under h1 as follows. Since under the alternate hypothesis x of n is equal to the DC level a plus w of n, and in order to find the distribution of x of n, we have to basically find the probability that x of n, that is a random variable x of n, is less than x of n under the hypothesis h1. And since x of n is equal to a plus w of n, this is a random value x of n, so this is equal to a plus w of n, the probability is equal to probability of a plus w of n less than x of n. And this probability distribution is equal to probability that w of n is less than x of n minus a. Therefore, the probability of x of n, the probability distribution of x of n under alternate hypothesis is equal to the probability distribution of w at x of n minus a. Now the likelihood ratio test is equal to the product n equal to 0, n minus 1, probability distribution of w at x of n minus a, divided by the product n equal to 0, n minus 1, probability distribution of w at x of n is greater than gamma. Now consider an example where we have probability distribution of wn is equal to sum of two Gaussian distributions, that is, say 1 by 2 normal distribution with mean equal to 0 and variance equal to 1, plus 1 by 2 a normal distribution with mean equal to 0 and variance equal to 2. So clearly the likelihood ratio test becomes the product n equal to 0 to n minus 1. The probability distribution is 1 by 2, 1 by square root of 2 pi exponential of x of n minus a, since we have x of n minus a in the variable. So this is minus x of n minus a whole square divided by 2. And the second part of the distribution is 1 plus 1 by 2, 1 by square root of 4 pi exponential of minus x of n minus a whole square divided by 4. So that's the numerator. And the denominator is the product n equal to 0 to n minus 1. So the distribution is basically sum of two quotient distributions. So it is 1 by 2 square root of 2 pi exponential of, and the variable is x of n, square over 2 plus 1 by 2, 1 by square root of 4 pi exponential of minus x square of n by 4. And this should be greater than gamma. So clearly this likelihood ratio cannot be simplified further. That means we do not have a simple test statistic. No simple test statistic. Thanks for watching.